This video is an explanation of question number 2 on the vector applications handout. So as you're looking at this problem, they're talking about two different forces that are acting on an object, and you want to try and find the resultant vector. So they're giving you the magnitude and the direction of the vectors. You need to first change those into component form so that you're going to be able to add them. So let's look at the first force. It says it's 250 pounds at an angle of 25 degrees with the horizontal. It's really helpful to make a sketch of what your forces look like so you can kind of get an idea which quadrant they're going to be in and whether your magnitudes and your direction make sense. So if it's an angle of 25 degrees with the horizontal, that means it's in standard position. It's coming up from the x-axis at about 25 degrees. This is, again, just a sketch. You don't need to measure it. If the question is talking about direction, remember directional angles are going to go from north, so they're going to go from the y-axis and then go in a clockwise direction. So you need to be careful with these application problems, whether you're talking about angles in standard position from the horizontal or whether you're talking about a directional vector. So this here has a force of 250 pounds. The magnitude of this vector, I'm calling it vector 1, is equal to 250. So if we wanted to change that into component form, you're going to take 250 times cosine of 25 degrees. That's going to give you the x-coordinate, and 250 times sine of 25 degrees. That's going to give you the y-coordinate. So you can change that, take your calculator, and you can just do this on your calculator. Make sure that in your mode that you're in degrees. And then you'll take 250 times cosine of 25 degrees, and that's going to give you 226, and we can just round to the nearest hundredth. You could store these to make them more accurate, but to make it a little bit simpler, I'm just going to round to the nearest hundredth here. And then you would take 250 times sine of 25 degrees, and that's going to give you 105.65. So what that's telling you is that you would go out 226.58 units, and then you would go up 105.65 units to get to the end point of that vector. And you want to think about whether that makes sense based on kind of the sketch that you had and the scale. You want to now do the same thing with your second vector. So this vector here, it tells you it has a force of 45 pounds. That's the magnitude of that vector, and it has an angle of 250 with the horizontal. So if you're starting here, this would be 180 degrees, this would be 270, so 250 would be about here. This is much smaller than the original one, so I'm going to just draw it small over there. And then you want to imagine that if we're going to find the resultant, you're going to place these two vectors head to tail. So you would kind of pick this vector up and move it so it would be right there. Then you would be able to find the resultant vector, which is going to go from this vector to from the tail of the first one to the head of the second one. Again, we want to change this into component form, so you would do 45 times cosine of 250 and 45 times sine of 250 degrees. I'm going to put that again into my calculator, and this gives me negative 15.39 and negative 42.29. Again, see if that makes sense. Does it seem reasonable that from here you would go left, so negative 15.39, and then down 42.29 to get to the end point, and that would be yes, so it makes sense. So now to find your resultant vector, you're going to just add the two vectors together. So I'm going to use an R for my resultant vector, and I'm going to simply add my vector 1, my force 1, and my force 2. and you can simply just add those components. So you could take 226.58 plus negative 15.39. That's going to give you the x coordinate, and then you would take 105.65 plus negative 42.29. So if I add those together, I should get 200, let's do this quickly, 226.58 minus 15.39. It's going to give me 211.19, and then 105.65 minus 42.29 is going to give me 63.36. Looking at your components, you want to think, okay, if I look at my purple one here, does it seem reasonable that I would go over 211.19 and up 63.36 to get to the end of that vector? This resultant should be less than this one. You can see that the line is shorter. So that's the component form, but that's not what they asked us. They asked us for the magnitude and the direction. So you now need to find the magnitude of the resultant vector, and you do that by essentially taking your two components, x and y, and putting them into the Pythagorean theorem. So you're going to just do 211.19 squared plus 63.36 squared, and take the square root of that. And it should give you 220.49. You want to include some units there. These forces were measured in pounds, so this resultant is also going to be measured in pounds. So the magnitude of that force is 220.49 pounds. And then you need to find the direction of that force. Here we're going to use trig, and you're going to do the inverse tangent, and then just take the relationship between the y value over your x value of your vector, and that should give you 16.7 degrees. Again, you want to make sure that based on your sketch that makes sense. It's in the first quadrant, so it's a little bit easier. Some of the other ones, if it's in one of the other quadrants, you might have to add or subtract from 180 degrees. All right, hope that helped. Let us know if you have any other questions.